Welcome to G Fun Facts Online. Imagine a world where the sky is ruled not by birds, but by reptiles. A world of immense forests and vast, warm seas. Now, imagine being born into that world as a creature no bigger than the palm of your hand, a tiny hatchling emerging from a soft, leathery egg buried in the sand. Your first breath is of air thick with the salty spray of a nearby ocean. But it's not a peaceful moment. A tempestuous wind howls around you, and rain falls in torrential sheets, turning the ground into a churning slurry of mud. For countless tiny pterosaur hatchlings, this was reality. From their very first moments, their lives were a desperate struggle for survival against the awesome and unforgiving power of Jurassic weather. Today, we're peeling back the layers of time to understand this perilous beginning, exploring how the first vertebrates to ever achieve powered flight began their lives amidst the ever-present threat of the storm. The Jurassic period, which stretched from about 201 to 145 million years ago, was a time of environmental extremes. If you could travel back, the first thing you'd notice is the heat and humidity. The Earth's climate was significantly warmer than it is today. Atmospheric carbon dioxide levels were estimated to be about 4 times higher than our modern levels, creating a potent greenhouse effect. Geochemical evidence tells us that this warmth wasn't just on the surface. Even the deep ocean waters were warm. Critically, there is no evidence of polar ice caps. This absence of large, cold land masses at the poles had a profound impact on global weather patterns. A world without ice caps meant a world with higher sea levels and a more uniform global temperature. Lush forests, dominated by plants we'd find exotic today, like massive conifers, cycads, and ginkgos, as well as vast fields of ferns, could be found at much higher latitudes than they are now. But don't mistake this balmy, tropical world for a tranquil paradise. It was anything but. The high global temperatures and the vast, warm oceans acted as a gigantic engine, fueling weather systems of immense and almost unimaginable power. The increased heat and moisture in the atmosphere likely resulted in far more frequent and intense tropical storms, hurricanes, and monsoons than we experience. While the lack of cold, polar air masses meant fewer of the intense winter blizzards we might know, the summer storms and rainfall events would have been on a completely different scale. We have direct evidence of this turbulent weather in the fossil record. Paleontologists have found fulgurites, which are natural glass tubes formed when a bolt of lightning strikes sand, fusing it instantly. The presence of these, along with abundant charred wood from ancient wildfires, confirms that violent thunderstorms were a common and dangerous feature of the Mesozoic landscape. This was the violent, chaotic world into which the young pterosaurs were born. And their first challenge began before they even hatched. Our understanding of how pterosaurs reproduced has been a fascinating detective story, pieced together from rare and remarkable fossil discoveries. We know that pterosaurs, like modern reptiles, laid eggs. But these weren't the hard-shelled eggs of birds. Instead, pterosaur eggs were pliable and soft-shelled, much like those of many modern lizards and turtles. This soft shell structure had a critical implication. The eggs needed a consistently moist environment to prevent them from drying out and killing the embryo inside. This led paleontologists to the conclusion that pterosaurs must have buried their eggs in sand or soil, just as sea turtles do today. Incredible fossil sites from around the globe have given us stunning snapshots of this nesting behavior. In China and Argentina, paleontologists have unearthed breathtaking collections of pterosaur eggs, some so perfectly preserved that they still contain the delicate, fossilized remains of the embryos within. One of the most significant of these sites, located in northwestern China, yielded over 200 eggs of a species called Hemipterus tianshanensis. The sheer density of these eggs, all found together in one location, has led to a powerful hypothesis. Many pterosaur species were colonial nesters. Like modern seabirds, they gathered in huge, bustling groups to lay their eggs, likely for safety in numbers. They often chose nesting sites on the shores of large freshwater lakes or rivers. This choice made perfect sense, as the soil there would provide the necessary moisture to keep their buried eggs viable. But this choice also placed them squarely in the path of danger. The very same sediments that so beautifully preserve these fossil eggs also tell a story of repeated catastrophe. The eggs are often found in distinct layers of lake sediment that show clear signs of disturbance from fast-moving water. The evidence points to a grim reality. Powerful storms would frequently batter these coastal nesting grounds, causing flash floods that would rip the eggs from their shallow nests and wash them into the nearby lakes, where they would be buried in mud. For a pterosaur colony, a single severe storm could mean the loss of an entire generation before the young even had a chance to breathe. In Chile, a fossil bed containing the scattered bones of thousands of pterosaurs is believed to be the aftermath of one such event, a single massive flood that completely overwhelmed a large pterosaur colony. But what if an egg survived the floods and a young pterosaur successfully hatched? What happened next? This question is at the heart of a fascinating and ongoing scientific debate. For years, paleontologists have been divided on the abilities of newly hatched pterosaurs, which have been affectionately nicknamed flaplings. Were they super precocial, able to take to the skies almost immediately after hatching, or were they altricial, born helpless and completely dependent on their parents for food and protection? Let's look at the case for the flight-ready hatchlings. A growing body of evidence strongly supports the idea that many pterosaur species, particularly the smaller ones that lived during the Jurassic, were ready to fly from birth. Detailed studies of pterosaur embryos from species like Peridostro and Synopterus have produced startling results. The embryonic skeletons are remarkably well ossified, meaning their bones were already hard and strong. Most importantly, the bones related to the wings were incredibly well developed, even before hatching. The humerus, which is the upper arm bone, is absolutely crucial for generating the powerful downstroke of flight. In these hatchling fossils, the humerus has been found to be incredibly robust. Proportionally, it was even stronger than the same bone in many adult pterosaurs. This suggests that their well-developed wings would have been fully capable of powered, flapping flight right out of the egg, not just simple gliding. It's also fascinating to note that the shape of a hatchling's wings was slightly different from an adult's. They were shorter and broader. This configuration might have made them less efficient for long-distance soaring, but it would have made them much more agile and maneuverable flyers. They could likely change direction in an instant. This agility would have been a crucial survival advantage, allowing them to hunt nimble insects or to dart away from predators in the dense, cluttered forests and environments they may have inhabited. This flap-early model paints a picture of a life of incredible independence from the very beginning. A young pterosaur could hatch, dig its way out of the sand, and immediately take to the air to fend for itself, with no need for parental feeding or protection. However, the story might not be so simple for all pterosaurs. Other fossil finds have presented a completely contrasting picture, suggesting that some hatchlings were far from independent. Remember that incredible collection of hemipterous eggs from China? Those fossils provided embryos that told a different story. While their thigh bones were well developed, suggesting they could walk effectively on the ground, their pectoral regions, the area where the powerful flight muscles attach, were significantly underdeveloped. Furthermore, these hatchlings appeared to be born completely without teeth. This would have made it impossible for them to hunt and feed themselves. This evidence points strongly towards a period of parental care, where the young flaplings would have been protected in the nest and fed by their parents until they were strong enough to fly and hunt on their own. So which is it? Were they independent flyers or helpless nest dwellers? The answer might be both, depending on the species and when they lived. More recent research suggests that the evolution of parental care may have been a key evolutionary strategy, particularly for the larger pterosaur species that emerged later in the Cretaceous period. While smaller Jurassic pterosaurs may have been self-sufficient from birth, the evolutionary path to gigantism the one that produced awe-inspiring giants like Pteranodon with a wingspan of up to 5 meters or 16 feet, may have required a fundamental change in reproductive strategy. The laws of physics place a constraint on egg size. You can only make an egg so big before the shell becomes too thick for the hatchling to break out of, or too fragile to support its own weight. This means that even the largest pterosaurs started life as very small babies. To reach their enormous adult sizes, they likely had to go through a much longer period of growth compared to their smaller cousins. During this extended and incredibly vulnerable juvenile stage, parental care in the form of protection from predators and a steady supply of food would have been absolutely essential for survival. It seems that this shift to a more nurturing parenting style may have been the evolutionary trade-off that allowed pterosaurs to break their size limits and achieve the colossal dimensions that made them the undisputed kings of the Mesozoic skies. But regardless of whether a young pterosaur took to the air within hours of hatching or after weeks of parental care, the sky was a dangerous place. Their small bodies and lack of experience would have made them especially vulnerable to the violent weather of the Jurassic. And recently, paleontologists have found direct, tragic evidence of this struggle. A remarkable study focused on 2 baby pterosaur fossils discovered in the famous Solnhofen limestones of Germany. These deposits, dating back over 150 million years, are known for their exceptional preservation. The 2 fossils were almost complete skeletons, and they showed clear signs of injury consistent with the powerful, twisting forces of severe wind gusts. The scientific conclusion is heartbreaking. These young flyers were caught in a powerful storm. The wind itself was so violent that it fatally injured them in midair. They were then swept into the calm, anoxic lagoons of the Solnhofen area, where they drowned and were quickly buried by fine sediment, leading to their incredible state of preservation. This finding also helped solve a long-standing paleontological puzzle. Why are fossils of small, juvenile pterosaurs so common in deposits like the Solnhofen limestones, while the remains of their much larger adult counterparts are significantly rarer? The answer, it seems, is that storms were a major and frequent cause of death, specifically for the young. Their smaller size, lighter bodies, and less powerful flight muscles made them far more susceptible to being overwhelmed by tempestuous weather. A larger, stronger, more experienced adult pterosaur would have stood a much better chance of weathering the storm and surviving. So let's put it all together. The life of a young pterosaur was a trial by fire, or rather, a trial by wind and water. From the moment it was laid as a fragile, soft-shelled egg on a flood-prone shore, its entire existence was at the mercy of the elements. If it was lucky enough to survive incubation without being washed away, it faced the immense challenge of its first flight. This was a challenge made all the more daunting by the constant threat of predation and the ever-present danger of a sudden violent storm appearing on the horizon. These magnificent flying reptiles, the very first vertebrates to conquer the air, began their lives in a world where the weather itself was one of their greatest and most relentless adversaries. Their fossilized remains, scattered by ancient floods and buried in the mud of storm-tossed lagoons, are a powerful and humbling testament to the stormy, perilous, and ultimately short lives of the Jurassic's youngest flyers.